Let's now understand the concept of back angle. Now, this back angle is practically redundant nowadays, no more used. But in the olden days, when we were dependent upon celestial navigation for our position fixing, back angle was used whenever the situation demanded. So let's try to understand what this back angle technique is and how does it help us to obtain the altitude of a body. Now, this back angle concept is used in those scenarios when the horizon is obscured due to any reason. The reason could be rain, it could be fog, it could be clouds, or there could be a coastline visible to you. Now, because of all these reasons, it is possible that the horizon may not be visible. Now, if the horizon is not visible to us, then we will not be able to take a celestial observation. We will not be able to take the true altitude of the body. For true altitude, we need to have the center of the body as well as the horizon both visible to us, and we measure the angle between these two using the sextant. So in these scenarios, when horizon is not visible, it will not be possible for us to take a normal sextant altitude of the body. Now, since in the olden days it was very, very important to take the sight, that was the only method available to us in open sea conditions where there were no land-based terrestrial navigations. This was the only means of position fixing. And if we are not able to take a sight, the vessel will be in doubt where the actual position is. So we tried our best to obtain the position line in whatever situation we were in. Now, in these scenarios also, it seems we will not be able to take the sight, but there is one possibility which is available. And that possibility is if the horizon on the opposite side is visible to us. Let me give you a practical example. Let us say you are coasting and you are coasting on, let us say, Indian West Coast. You are passing Mumbai and moving in the northwest direction. Now you have the coastline on your starboard side. Now let us say the sun rose and at about 9 o'clock, 10 o'clock, you went on the bridge and you wanted to take a sight, but you will have the coastline and the horizon will not be visible to you. Now this is where the back angle technique can help you. Instead of using the horizon in the direction of where the body is, we can use the horizon opposite to it and obtain the altitude of the body. Now, how is it done? Let us try to understand using a diagram. You see this diagram now. We have the earth in the diagram. We have the earth. Then we have the center of the earth at this particular place. We have the observer at point O. Observer has got some height of I also. You can see he is above the surface of the earth. C represents the center of the earth. And the celestial body which we are trying to observe is this particular star named as X. Z represents the zenith of the observer. Now, this line which you see passing from C, R dash, passing from the center of Earth, represents the rational horizon of the observer. Rational horizon plane passes through the center of the Earth. You can see it passes from the Earth center, and every point on it is 90 degrees away from the zenith of the observer. So this is our rational horizon. Now, from the observer's eye, if we draw a tangent to the surface of Earth, from the observer's eye, we draw a tangent to the surface of Earth. You see, this is the tangent in one direction. This is represented by OV dash. This represents the visible horizon of the observer. If you see on the opposite side, then from the observer's eye, you draw a tangent, you see OV is the visible horizon of the observer. Now, if you draw a line or a plane passing from the eye of the observer and parallel to rational horizon, you see this is the observer's eye and we have the rational horizon as R dash. This is the plane of the rational horizon. So from the observer's eye, if you imagine a plane which is parallel to the plane of the rational horizon, which is represented by S dash in the diagram, this is the sensible horizon of the observer. This is the definition of sensible horizon of the observer. So we have the sensible horizon also here represented by S dash. Now the situation is such that in the direction where the body is, you see this body X is in this particular direction. In a normal scenario, we would have used the visible horizon OV dash to obtain its altitude. But the situation is such that this particular horizon is not visible to us. There may be coastline, rain, fog, clouds as discussed earlier. So this side of the horizon is not visible to us. So that's why I have put a cross over here. But the horizon on the other side, which is OV, diametrically opposite to the direction in which the body is, exactly reciprocal opposite, this side horizon is visible to us. So if you have coastline on one side and the other side is clear, you will be able to see the horizon on the other side. So horizon on the other side is visible to us. This is the scenario, or this is the situation where the back angle method can help us. So even though the horizon in the direction of the body is not visible to us right now, we can still obtain the altitude of the body using the back angle technique. Now let's try to understand what this technique is. Now in a normal scenario, if this coastline or rain or fog or cloud was not there and the horizon was visible to us, OV dash horizon in the direction of the celestial body was visible to us, we would have obtained this particular green color angle using our sextant. This is the angle which we would have obtained. This is the angle between the center of the body, represented by OX, and between the visible horizon of the observer, represented by OV dash. So this angle XOV dash is what we would have obtained from our sextant. Now once you obtain this angle, the correction what you apply to this angle after the instrument error, after the index error, the next correction which we apply is the dip correction. The dip correction. Now what is the dip correction? Dip correction is basically the angle between the sensible horizon and the visible horizon. Let me show you here in the diagram. You see this particular maroon color angle. This is the angle between the sensible horizon, represented by SS dash, and the visible horizon, represented by OV dash. This is known as the dip angle. The full name of the dip is dip of the sea horizon. Basically, it tells us how much is the visible horizon dipping below the sensible horizon. That's why we call it dip. So we would have applied the dip angle or the dip correction to this angle which we have earlier obtained. We have seen the dip correction now applied here. Now once you apply this dip correction, the maroon color angle is subtracted. You would have obtained angle XOV. This was the apparent altitude of the body. So to the apparent altitude, we would have applied the total correction and we would have obtained the true altitude. This would be the normal method when the horizon is visible to us. But now we do not have the horizon available to us because of any of these reasons. So we cannot follow this particular method. So what do we do now? Now, since the horizon on the opposite side is visible to us, that is OV, this side of the horizon is visible to us, instead of measuring the angle to the normal horizon, we measure the angle from the center of the celestial body to the horizon in the opposite direction, represented by the blue color angle in the diagram. The blue color angle which you see is the angle between the center of the body and the horizon on the opposite side to which the body is. So we have used the sextant to obtain the angle between the center of the body and the horizon in the opposite direction. Now, obviously, this angle will be more than 90 degrees. A normal sextant altitude would always be less than 90 degrees, but this being a back angle observation will be greater than 90 degrees. Its value will be more than 90 degrees. So if you get a question in your exam where the angle is given as more than 90 degrees, don't think that it is a misprint. It could be a back angle observation. So we have obtained this back angle now. The back angle is obtained. Now, how do we proceed ahead from here? Now, the blue angle which we have obtained is angle XOV. X is the center of the body, O is the observer's eye, and V represents the horizon in the opposite direction. Now, to this angle, after applying the index error, obviously that is the instrument error, we again apply the dip correction as usual. We would be given the height of eye of the observer in these questions. So we get the dip correction and we apply the dip correction to this blue angle. So let us see what happens once we apply the dip correction. You can see the dip correction now represented by the maroon color angle. This is the dip correction applied to the horizon on the opposite direction, reciprocal direction. So once you apply the dip correction, the angle which we have now obtained is this blue color angle. The angle which is available to us now is XOS. And if you look carefully, this particular angle is basically 180 minus apparent altitude. You can see the sensible horizon, SS dash. It is a straight line. It is a plane, or in this diagram, it is a straight line passing from the eye of the observer and parallel to the rational horizon. So the angle which we have obtained now, that is the blue color angle, and the angle which we require, which is the green color angle, they will add up to 180 degrees. So if we have obtained the blue color angle, 180 minus this angle would give us the apparent altitude what we require. So 180 minus the blue color angle which we have obtained, we call this also as apparent altitude in the back angle calculation. Once you do 180 minus apparent altitude, you get the corrected apparent altitude. The green color angle is now called a corrected apparent altitude. So once you obtain the apparent altitude, further calculation is easy. It is exactly same as we did before. We apply the total correction and we get the true altitude of the body. So this is how we obtain the true altitude of the body using this back angle concept.
Beta, have a good look at the diagram and let me know if you have doubts at any of the steps.
Sir, in the end, that total correction will look for the corrected apparent altitude, right?
Yes, that's right, beta. Total correction will be applied to the corrected apparent altitude, which is the green angle. Okay. Shall we move ahead then, beta, if there are no doubts?
Sir, back angle and X meridian are two different things, no, sir?
Yes, beta, they are totally different things. Back angle is a method of taking the altitude using a sextant. X meridian is a technique which is used to solve the site, calculation technique.
Yes, sir. So this angle XOV, so this also is on the horizon, no, sir, but on the opposite side, right, sir?
Yes, that's right. It is with the horizon on the opposite side.
Okay, sir. Okay, understand. So the horizon, which is towards the body, is not visible for some reason. So that is why we take it to the opposite side.
Right, beta, that's right.
Altitude
सर वो
from
जो
the other
सेक्सटेंट
horizon.
सेक्सटेंट पे हम रीड करते हैं 90 के अबव जो ऑल्टीट्यूड आता है, हाँ, क्योंकि सर आर्क तो उसका 60 होता है, तो इट विल कम अगेन फ्रॉम 60 टू अबव सर, फ्रॉम बिहाइंड.
No, beta, the arc of the sextant is 60 degrees, but you see there is a reflection when we have a
हाँ सर,
mirror
वो
on the sextant.
120 तक.
It can measure up to 120 degrees. Okay, let me explain a little bit more about this. Let's discuss about it.
Now going a little more deeper into this back angle concept. The first thing is when you practically use this method, uh, it is not so simple and straightforward. To observe this back angle or to obtain the back angle of the body, practically if you are doing it on board, this will not be asked to you. What I'm going to explain now is will not be asked to you during the written exams, but certainly during orals, somebody may ask you, how do you obtain the back angle of a celestial body? So to obtain the back angle, when you take your position, in normal cases, you keep the body right ahead of you or you face the celestial body whose altitude is to be taken. But in case of back angle, you face in the direction opposite to where the body is. Let us say if you are taking a sun side, the sun is east of you, then you will have to face towards the western horizon and the sun or the celestial body will be at your back. So that is first thing. Now, once you face in a direction opposite to where the celestial body is, then you pick up your sextant, you point it towards the horizon in the opposite direction. Now you have to bend backwards. So you need to do a little warming up also. You should not fall behind. Either you can have some support at your back, maybe a compass repeater or something, or you can have somebody else assisting you from the back so that you don't fall down. You will have to bend backwards to capture the body, to capture the celestial body. So you have to bend backwards so that you are able to see the body through the telescope of the sextant. So you have to face opposite to the body. Holding the sextant on your hand, you have to bend backwards, taking your or bending your back towards the body, and you have to capture the body in the telescope of the sextant. Once the body is observed at the telescope of the sextant, then you move the sliding arm, and when you move the sliding arm, you will see the body will start to move or a projection or shadow of the body will start to move like this. You bring that projection or shadow to this particular horizon, and then you measure the angle on your sextant. So this is how you observe a back angle. Face opposite to the direction where the body is. The body will be at your back, and then you pick up the sextant, you bend backwards and you capture the body in the telescope of the sextant. As you move the sliding arm, you will see the body will start to move towards the horizon on the opposite direction. You bring that body down to the horizon in the opposite direction, which in this case is OV. And once the body's projection or image comes here, you observe or note down the reading of the sextant, and this is the back angle of that particular body. So to this back angle, you apply the index error, you apply the dip correction, you will get 180 minus apparent altitude. You subtract it from 180 and you get the apparent altitude of the body, thus giving you a lead into how the site is to be solved. Now, in the olden days, as I told you, when there was no GPS and in open sea, we were dependent entirely on the celestial navigation position fixing. This was a important method which was used, especially if there is a coastline and you are not able to take the site and the horizon on the opposite side is clear. So using this method, we were able to obtain the PL even though horizon in the direction of the body was not clear to us. Now, second important thing related to this particular method, the maximum angle which our sextant can measure. Our sextant is basically derived from the word 1/6 of the full circle. So full circle is 360 degrees. Our sextant, the arc is 1/6 of that full circle. So the arc of the sextant extends to 60 degrees. Now, because of reflection of light in a mirror, in the index mirror and the horizon glass, there is one reflection. Because of that reflection, we are able to measure twice the amount of angle. So with a 60-degree arc, we are able to measure maximum 120 degrees of angle using our sextant. So the maximum limit of the sextant is 120 degrees. So this means the maximum blue color angle which we can measure is 120 degrees. 120. So this tells us that the body's altitude should be greater than 60 degrees for it to be observed using the back angle. Because if the altitude of the body is less than 60, let us say the body has an altitude of 30 degrees only. With a 30-degree altitude, the back angle gets a value of about 150 degrees approximately. Now 150 degrees is something which we cannot measure, which is beyond the capacity of our sextant. So to observe a body using the back angle technique, its altitude should be greater than 60 degrees. So again, this could be asked to you during oral exams related to the back angle observation. So with this, we complete this topic of back angle observations.
So any doubt, beta, in this topic anywhere?
Sir, in this figure, sir, which angle is our true altitude? The blue angle?
Okay. Okay. बेटा अगर ट्रू अल्टीट्यूड की बात करें तो I'll tell you.
XCR.
Yeah, X is the body, C is the center of the earth, and R represents the rational horizon. X, C, R dash. Okay, this is R dash. X, C, R dash is the true altitude.
Okay, sir.
Okay, beta. The definition of true altitude is the angle at the center of the earth contained between the center of the celestial body and the rational horizon of the observer. So XCR dash is that angle. Now a doubt could arise in your mind, sir, how do we obtain this XCR dash from the green angle, right?
Apply the correction, no, sir, total correction.
Yes,
Total
that's where
total correction see the
total correction comes into the picture. Once you apply the total correction, it converts the apparent altitude to the true altitude. Okay, any more doubts, beta?
सर इसमें अपर लिम्ब सन की लोअर लिम्ब हो जाएगी ना जब अपन घुमा के लाएंगे तो?
Yeah, that's right, beta. Now you see, if you are doing this technique with sun or the moon, now what will happen is, if you have the sun here in place of the star at X, let us say if you take this back angle using the lower limb of the sun, okay, let me show it on a whiteboard. We are taking a altitude of the sun and the sun is here. So observer, let us say the observer is at this particular location. Now when you are taking the altitude of the sun, let us say we are taking a normal altitude, the horizon is visible to us. Now when you take a normal altitude, you have to select the limb of the sun, either lower limb or the upper limb. So when you take a normal altitude, okay, which limb you want to take, beta? I'll take example of one, upper limb or lower limb?
The lower limb.
Okay, so we want to take the altitude of the lower limb. So what we do is, if you join a line from the observer to the lower limb of the sun, this is the lower limb of the sun. So when you bring the sun down using your sextant and the lower limb touches here on the horizon, this is the angle which we measure. So basically this is the lower limb altitude of the sun. Now in case of a back angle, this was a normal observation. We would bring the lower limb of the sun and when it touches the horizon, we measure that angle on the sextant and it will be this angle. Okay, the blue angle which we have shown in the diagram. Now let's say the horizon on this side is not visible to us and we want to obtain this altitude only, the lower limb altitude. So what we do now, let me change the color. What we do now is we take the sun on the opposite side of the horizon. Now we want the altitude of this particular limb. So when you take the sun on opposite side of the horizon and the sun comes here using your sextant, you bring it here. जो ये वाला limb है बेटा, when it comes here, this limb will touch the horizon when the sun is in this particular way. So जो limb को मैंने highlight किया है, you see it is the same limb. Correct, beta? Are you able to understand?
Yes, sir.
So you see, when we take the sun to the horizon on the opposite side, what was lower limb actually becomes the upper limb on this side. So on this side, if you see, this is the upper limb observation of the sun. So this simply tells us that whenever we take a back angle observation, the limb of the sun changes. So if in the question they tell you a back angle observation of the sun was taken and the angle came to 100 degrees. 100 degrees was the back angle and it was the back angle of the upper limb of the sun. So you can see here in the diagram, this angle what they are talking about is 100 degrees and it is the observation of the upper limb. The back angle observation is of upper limb. Now when you subtract it from 180 and you get this angle here as 80 degrees. You see, this 80 degree on this side would be the altitude of the lower limb. So as soon as you subtract it from 180, I do 180 minus 100. As soon as we subtract it, the limb also changes. Upper limb gets converted to the lower limb. So remember this when you are doing the back angle observation of the sun, that if they have given you a certain limb, once you subtract from 180, the limb should change. So once the limb has changed to lower limb, now you will apply the total correction basis the lower limb observation, not the upper limb observation which was initially given. Upper limb was applicable for 100 degrees. Lower limb is applicable for 80 degrees. So is it clear now, beta?
सर जब लोअर लिम
Yes.
का हम लोग वी आर टेकिंग बैक एंगल, तो जो टोटल करेक्शन होता है वी हैव टू अप्लाई फॉर द लोअर लिम वाला ही जो नॉटिकल एल्मैक में मिलेगा, करेक्ट सर?
बेटा आपको क्वेश्चन में उन्होंने बैक एंगल दिया है, राइट?
यस सर.
Let's assume any back angle. Let's say they have given you 110. This is the back angle given. This is more than 90, so we know it's a back angle. And what is the limb which they have given to you?
लोअर लिम सर, एनी लिम सर.
Okay, assume anyone. So it was given in the question that this was a lower limb observation. So back angle has been taken using the lower limb of the sun. Now what I'm saying is when you subtract it from 180 minus 110 when you do, so the answer would be 70 degrees. 70 degrees will be the actual angle. Now as you subtract from 180, the limb also changes. This 70 degree will be the altitude of the upper limb on the other side of the horizon. So when you apply the total correction, you will be applying it for the upper limb correction, beta.
Okay sir, okay, understood. So if lower limb back angle, then you apply the total correction of the upper limb, 180 minus.
That's right. That's right.
Okay sir, thank you.